Welcome, Mr. Sutton here with the Pre-Cal Honors 6-1 Part 2 homework solutions on polar coordinates and graphs. For number 8, we're trying to get polar coordinates for this rectangular point here. So we'll start by getting our radius, Pythagorean theorem for that. So we're doing the square root of 5 squared plus 2 squared. So we'll just leave that as radical 29. And then for the angle, we've got tangent equals y over x, so we need inverse tan then of 2/5. And let's plug that in the calculator. So double checking first that you're in degrees mode. Plugging this in, we've got 21.8 degrees. Now let's check our quadrants. The original point is quadrant 1, positive x and y. This angle that we just got is also quadrant 1. Since the angle and the actual point match, that means we have the correct version of this angle. So we'll just stick this angle in with our radius here. So radical 29 comma 21.8 degrees is our polar point. For this problem, we're trying to take these rectangular coordinates and come up with a polar coordinate system for these. So we're going to need two things for that, the radius and the angle. To get the radius, we basically use the Pythagorean theorem on the x and the y value that they've given us here. So we've got square root of negative 1/2 squared plus radical 3 over 2 squared. And going through and doing this, this is going to be positive 1/4 plus 3/4, which just adds up to 1. So we have the square root of 1, which is also 1. So there's our radius. Now we need to get the angle. For that, we have tan of theta equaling y over x in general. So that means that to get my angle, I need to do the inverse tan of y over x, or radical 3 over 2 over negative 1/2. So this is our situation here. We're inverse tanning y over x. Now you can do this right away on the calculator, or if you want, you can reduce this to negative radical 3 if you do same change flip on this. Still got to take the inverse tan of that though, so let's do that now. So making sure I'm in degrees mode, inverse tan of negative root 3 gives me negative 60 degrees. So that's kind of my starting point. I don't know for sure that this is the angle, though. I have to check the quadrants. The original point that they gave us, this is going to be a negative x and a positive y, so we're in quadrant 2 for the actual point. Now the angle here, negative 60, this is normally a quadrant 4 angle, which is not quite what we need. To make sure that the angles quadrant matches the points quadrant, we need to add 180 to the angle. So that'll give us 120 degrees, and that's our true angle here. We're going to have 1 comma 120 degrees for those polar coordinates. To get the polar coordinates for this pair of points, we need to find the r and the theta value. For the radius, we're doing Pythagorean theorem on the x and the y that they've given us here. So we've got these two things squared, added together, and square rooted, like so. Now if you square each of these, you've essentially got 2 over 4, or 1/2. So you've got 1/2 plus another half, which is just 1. Square root of 1 is 1. And then to get the theta for this, we know that tan of theta is y over x. So we can do inverse tan of y over x here. This is essentially the inverse tan of 1, which is going to come out to 45 degrees. So 45 degrees and the original point here, those are both in the first quadrant. Since the quadrants match, 45 degrees is our actual angle. We don't have to add 180 here. We can just take the angle and call this 1 comma 45 degrees. To get polar coordinates for this point, let's find the radius first. That's Pythagorean theorem of the x and the y value that they gave us. So we've got those two things being squared, added together, and square rooted. So let's see here. I've got negative 2 squared and radical 2 squared, so that's essentially 4 times 2, or 8. And we're doing that twice, so 8 plus 8 is going to give us 16 inside, whose square root is 4. So there's our radius. Now for the angle, we know tan of theta is y over x. So then the theta is going to be the inverse tan of y over x. Since we're essentially dividing something by itself, this is just the inverse tan of 1, which is 45 degrees. Now the original point here, we have negative x and y, so this original point is actually in quadrant 3. However, the angle that our calculator gave us is in quadrant 1, because our calculator can only give us angles in quadrants 4 and 1 for this inverse tan function. So we need to make sure the quadrant matches for the angle. So we're going to change this angle by adding 180 to get a quadrant 3 version of that, and that ends up giving us 225 degrees. So then our polar coordinates will be 4, 225 degrees. For number 5, we're given this pair of rectangular coordinates, and we want to turn this into polar coordinates. So for that, we need to find the radius and the angle formed by this rectangular point. Let's start with the radius. For that, we'll do the Pythagorean theorem. So we've got r squared equals square root of x squared plus y squared. So we've got negative 2 squared plus 2 squared. 4 plus 4 gives us radical 8. And we can simplify that radical to 2 radical 2. So that's our radius that we'll put in our polar coordinates. Now we need the angle itself. So for that, we need to do inverse tan of y over x. So that's going to be inverse tan of 2 over negative 2. Inverse tan of negative 1, I just happen to know that comes out to negative 45 degrees, but you could do it on a calculator. So now at this point, when you've got your angle, you have to check the different quadrants that we're in. The original point right here, negative 2, 2, that's up in quadrant 2, negative x, positive y value. This angle, negative 45, that is in quadrant 4. Since we have a mismatch between these quadrants, we need to find the quadrant 2 version of 45 degrees, negative 45, which we can get by simply adding 180 degrees to it. So that'll give us 135 degrees as the true angle that matches this point. And then if we write our coordinates, we've got 2 radical 2, 135 degrees. For number 6, we're trying to turn this pair of rectangular coordinates into polar coordinates. Let's start by getting the radius. So we've got our Pythagorean theorem here to find that radius. We've got square root of root 2 squared plus negative root 2 squared. So that's 2 plus 2, which is 4. Square rooting 4 gives us 2 for the radius. Now to find the angle, we'll do tangent for this one. So we'll have to do inverse tan of negative root 2 over root 2. Well, that's really inverse tan of negative 1, which I happen to know comes out to negative 45 degrees. Checking our quadrants, the original point is in, let's see, we got positive x, negative y, that's quadrant 4. This angle here is also quadrant 4. Since the quadrants match, that means this is the actual angle that we need. So we don't have to add 180 for this. So we'll just take this angle and this radius, put those together, and there's our polar coordinates. For number 7, we're trying to turn this pair of rectangular coordinates into polar coordinates. Let's start by getting the radius. We'll use Pythagorean theorem. So we're doing square root of negative root 3 squared plus 1 squared. So that's just square root of 3 plus 1, which is 4. So square root of 4 then is 2. Now we have to find the angle. Now tan, we remember, equals y over x. So if we do inverse tan of 1 over negative root 3, that'll give us our angle. For this, I'll use the calculator. So make sure your calculator is in degrees mode for this, unless you want to do everything in radians. And then we'll do second tan, and we'll do 1 divided by, let's see, negative square root of 3. And that's going to come out to negative 30 degrees. Double checking our quadrants, we have a negative x and a positive y value for the original. That puts us in quadrant 2 for the rectangular point. This angle that we just got is a quadrant 4 angle. And I mean, inverse tan can only return things in quadrants 1 and 4, but we need the quadrant 2 version of this angle so that it actually matches the actual rectangular point. So we'll add 180 to this to get it over in quadrant 2. So that's going to be, let's see, negative 30 plus 180 is 150. So our actual rectangular coordinates then, 2, 150 degrees.